Okay, now let's take a look at the actual instruction formats. So most of the instructions have two source operands and one target operand, and mnemonic indicates the actual operation such as addition, subtraction, bitwise AND, bitwise OR, and likewise exclusive OR, not OR, or NOR is also available. Other commands implement arithmetic if, so they evaluate a condition looking at equality or less than or not equal, greater than, greater or equal, and then if the condition is true, the target register gets value of 1 and 0 if the condition is false. And it is advisable that you write pseudocode like this in the comments. MIPS comments begin with the $, and you can also add more information next to this pseudocode instruction explaining specific meaning. Very similar instructions that involve immediate operands, basically constants embedded directly in the format of the instruction, have this form with instruction mnemonic, essentially using an extra suffix for immediate format, and arithmetic if versions are also supported, and you can both use decimal and hexadecimal format for your literal values. Integer multiplication result is always a 64-bit number, which requires two registers, and internally in MIPS hardware there are registers named high and low, but there is no direct access to high and low. Instead, there are move instructions dedicated to low and high, and if you don't expect your result to overflow the 32-bit range, then there is this pseudocode or macro instruction, multiply, which takes two operands, the source operands for multiplication, sets the result at the end of its execution to the low portion of the multiplication result. And this is how the macro instructions work. Basically, its mnemonic is specifying not a direct command available on the CPU, but a definition of a macro, which in this case expands to these two lines. Integer division is similar to multiplication, and a single operation computes both quotient and remainder. So it simultaneously updates both low and high, and the low contains the quotient and the high contains the remainder. So you use the same instructions to obtain those two computation results. Large portions of our instructions not doing any computation, but actually moving values from one place to another. So these are instructions using registers. So if you want to assign one register value to another, you can use move instruction. And of course, the direction is similar to the direction of the assignment in high-level programming languages. So it's basically moving this way, using right-hand side as the source and the left-hand side as the target. Unload immediate allows to assign a constant value to the register. Here's a character literal, which specifies a specific character, which is similar to obtaining the encoding of this character and assigning the bit combination to the target register. When you need to get access to values stored in the data segment, you can use load address instruction. In our Hello World example here, we placed a label in front of this directive that reserves character in the data segment, and when we needed to print the message, what we do is that we use load address instruction to retrieve the address associated with this label and load it into the register that we want.